all set with this? Cool. Hi everyone, my name is Garcia Puyol. I am an architect and I have a background in computational design. In fact, I used to work for Core Studio with these guys, and this morning Jonathan mentioned how the company had these R&D projects that people could apply for and get to work on ideas that did not exist before. That's how I got started with virtual reality, so I have to say I'm very thankful to the whole team and the company because I got my hands dirty almost 3 years ago. I am now the Director of User Experience and Integration at IrisVR, and today I'm going to talk to you about what we're doing there to provide you with tools and workflows for collaboration in architecture, engineering, and construction using virtual reality. So to start, I'd like to tell you a little bit about us. We are a startup. We're based here in New York City. We are now 22 employees, out of which a third or so have a background in architecture or design. We take huge amounts of coffee to make sure that we meet our deadlines. And we have now a little bit over 40,000 users across the world. I have divided this presentation into 3 parts. So this first part, I will cover why virtual reality is relevant in the AEC industry. And so to start, here's a timeline of how technology has evolved for us in AEC. So in the 1400s, Brunelleschi demonstrated the principles of linear perspective, followed by Alberti and Da Vinci. Then in the 50s, like a lot later, the drafting workshops became common practice, where a lot of people would spend really large amounts of time developing sections, drawings, details. And only in the 80s, CAD was introduced. So with computer-aided design, we could model 3D objects using a computer, and the space shuttle was possible. A little bit later on, computational design was born, and so very complex buildings such as the Guggenheim Museum in Bilbao by Getty were made possible. Only in the early 2000s, we got building information modeling. So now we can embed large amounts of data into our projects and every single element that composes that project. Yet we have this amazing technology. We all agree on that. And all of them do things well in a different way, like Brian and Andrew were mentioning earlier today. Yet, in a typical conversation, you have a creator, a designer, architect, engineer, contractor that has a very clear idea in their mind about how something will feel like, something will look like, but there's another person that is in that conversation that has no clue really what's going on, even if they're using a scale model like what you see here. But most commonly, you're using 2D drawings that don't communicate the design intent. And so the communication is flawed. There's someone that is left with many questions, and that leads to many errors. And this doesn't only happen at the design level phase. It also happens on construction. So this is an amazing piece of work, what you see here. So on the construction side, somebody will not go ahead and ask the right questions and go ahead and build based on their intuition. This is very expensive. And as Frank Lloyd Wright put it, you can use an eraser on the drafting table or a sledgehammer on the construction site. We think that with virtual reality and 3D models, which is what we do today, we can catch these errors early on. And so to illustrate that, I have brought these examples, and I'm gonna let them sink in. I think the picture on the bottom right had some title called Stairways to Hogwarts. The thing is that I think those never moved, so they were leading nowhere. And again, I'll say that what we want to do with virtual reality is to move from a culture of interpretation of 2D drawings to one of confirmation of 3D spaces, so that things like this, that again are very expensive and don't look or don't speak, they pretty much speak poorly of our profession, happen or are common. And while we do that with virtual reality, we also want to change what the day-to-day work of many professionals is like in our industry. So this is how it currently goes. There's a first phase of conceptualization, so ideas are discussed in a team, Then that team spends quite some time developing 3D models and 2D drawings out of those 3D models. Very long hours are spent doing a lot of manual work. We have all done those all-nighters, tons of coffee, Red Bull, you name it. And we had to do those presentations the next morning, not knowing really where we had our head or our feet. So the frustration also comes from the fact that you're developing these amazing ideas that are three-dimensional, and then you're showing them on a 2D screen, and a lot is lost. And then this just goes on repeat. What we're thinking is that there's another way, and we can have automatic and instant conversion of those 3D files into virtual reality experiences, so that not only you, but also your colleagues, anyone that you're working with, consultants, can get to see and experience in first person in a true-to-scale way what that building, that design will look and feel like. So here I wanted to illustrate something that we find very important. This is from Mortensen Construction. Not only we can use virtual reality to work with contractors, and so to avoid those mistakes on the construction side, but we can bring onto the discussion the key stakeholders, so people that will have to live with our decisions as designers. In this case, they worked closely with nurses and doctors in a hospital. So let's imagine like a mistake in one hospital room is very costly and it's inconvenient, but it's not the end of the world. Now imagine that same mistake populated over hundreds of rooms. That becomes, again, like something that is very expensive to solve and to put a fix, but it speaks poorly of how we design and what we're doing. And this morning it was mentioned too that we are creators of spaces, but then we never get feedback of what we got, what we delivered to the final user. So what if we could involve these people at the very beginning and design accordingly? Now, the second part of the talk is called Immersive Design Review. And Immersive Design Review is using the traditional design review with the addition of immersive technologies such as virtual reality, so that communication becomes intuitive and easy, and so the design intent is clear to the other people involved. To do that, we've created Prospect. That's the name of our desktop platform. And it integrates seamlessly with the majoring authoring tools like Revit, SketchUp, Rhino, Grasshopper, and OBJ. With one click, or drag and drop as you see here, you can create, you can see your file in virtual reality quickly, and it's something that you can share with others. We have support for the two main headsets. For those of you who are not familiar with them, there's the HTC Vive that is very convenient if you have the luxury here in New York, at least, of real estate and setting up what people are calling VR labs or VR rooms for demos with clients and such. Those work really well because they have controllers that trackers that you can set up on the walls, and you can walk around the room. But we also have support for the Oculus Rift, and so if you're looking for a solution that works well on your desk, that's the one for you. And both of them require a really good computer and GPU, and they have controllers that allow you to interact with the environment, the virtual environment in front of you. So now I'd like to tell you a little bit about what we use for reference to design better tools and workflows for this immersive design review. So we want to support design workflows that traditionally use physical environments. So by that we mean, how do people collaborate currently when they get around the table and they have to be together in the same physical space? But also, how do they interact with the models and the documents that they have in front of them, right? Because in those situations, gravity is one of the things that is important. If they grab a model and they release that, it will fall. We also look at how we can support digital workflows that are data rich, so BIM environments. We want to make sure that all the different programs that we have support for, we can bring that data into virtual reality in an easy way so that people can make more informed decisions using virtual reality. But also, we're looking at how computers, tablets, phones, how users interact with those, and the typical expectations that they have from those platforms, and how we can translate those interactions into something that makes sense for you in virtual reality. The third one that we're using as reference is the latest technology available in virtual reality. Because if we can bring joy and magic into an architecture, engineering, and construction meeting, we should definitely do it. And there's amazing development happening, not only on the real-time engines, but also in how people are making use of their APIs and to create something as amazing as this. This is from Tiltbrush, Google's artistic application. So I'm going to give you a few examples of how we're looking at these 3 points that I just mentioned. The first one is navigation. So we have support for you to walk around the room, just like you would in a physical environment. But also we're bringing that magical effect that I was mentioning before. So you can go from scale model mode into first-person mode by using the controller, pointing somewhere, pressing the trigger, and being taken to that new location. But at the scale model mode level, not only are we allowing you, like you would in reality, to grab a model and pick it up and rotate it, but we allow you to scale it up in front of you. That would have never been possible with a real model. And so wouldn't be the fact that you can section a model unless you wanted to break it. And in terms of simulations, the files are geolocated in the original programs that you use, Revit, Rhino, and SketchUp. So we can use that to allow you to go to a specific point in the model and take a look at what that will feel like at a specific time of the day and at a specific time of the year. The idea of having to make a model and setting up a tripod outside and take a picture every hour, if you guys haven't done that, I have, and so I don't recommend it. It's a thing of the past, or even those renderings that take a few hours to get done, there's no need for that anymore. The real-time engine allows you to do this. And in general, I like to think of architects as storytellers with a bigger goal than getting something built. Architects don't just make houses, offices, schools, museums, or hospitals. They create environments for happy families, successful companies, thriving students, creative artists, and patients that heal fast. The way in which we experience a space matters. And so that's the story behind each key viewpoint, which has been carefully crafted. We have support for those moments by reading data from Rhino, Revit, and SketchUp. And so when you're in virtual reality, you can go through those and find a point in the model that is important to you, or you can walk somebody else through that process so that they get to see the building the way it's meant to be experienced in first person and before it gets built. On the more technical side, we have added support for things such as being able to measure 2 points, so making sure that things are correct, again, trying to minimize the amount of mistakes that we eventually see on the construction side, but also being able to adjust the visibility of layers in virtual reality so that you can get an understanding of what the layout of the space is, maybe compare design options, and also discover opportunities for design that you wouldn't have seen just looking at a 2D plan. And we're currently putting a lot of energy into improving our support for annotations and markups while in virtual reality. And by popular demand, we have added support for different colors and brush sizes, and the ability to not only take annotations here at your hand, but also being able to project onto surfaces and make meaningful annotations throughout the model. And I'm especially excited about this one feature. This is the latest that we have released. It's the Inspect Element tool. It allows you to select an object while you're in virtual reality and view some of their properties. In this case, we have support for layers and materials, and so if you want to turn off the layer that the object belongs to, you can easily do that using the menu. You can also flag that element and mark it as something that needs to be fixed later on. And we're planning on adding far more support for it so that we have access to the family and the element name in the case of Revit files. And a lot of BIM data is coming very soon. Because the idea is that you walk around your building in virtual reality, you're marking up a bunch of objects. These objects need to be fixed. But then the question of where are these objects? I need to go back to my file and get them fixed, get them replaced. And so what's coming is the ability to download a list of all the elements that need to be fixed. And so they will have the date of the VR session, the username, or the name of the user who flagged it, the family name, and element IDs. And the idea of this is that using out-of-the-box tools such as the Select by ID, I guess a button here in Revit, you can copy and paste those IDs, and they will automatically get highlighted for you, so you can go ahead and fix them. And for the power users out there who love Dynamo as much as I do, will be able to make use of it, since it will be a CSV file that you can use to automate making changes in bulk, or apply different parameters to each and every of those. If you are a Rhino user, we'll soon have support for Rhino and Grasshopper as well. So don't despair. Now, the last part of my talk is working together in virtual reality, and whether you're working with clients, colleagues, or consultants. This first part, I hope the video is playing, yes, relates to what we call takeaway or take-home virtual reality experiences. In Prospect, we've recently added the ability to take 360 panoramas. So usually if you use any other engine, it will take a few hours to grab that 360 image of the spot that you are currently in. So once that picture has been taken, it gets saved locally on your computer, and then you can use Scope, which is our mobile app, and upload it to our website. And once that gets uploaded, you can preview it here on the website. It's like a regular 360 viewer, which makes it really easy to make sure that everything came through correctly. And then it will be available to you on the app. You can share that code with clients, and so putting your phone into a Google Daydream headset or a Google Cardboard Gear VR, we have support for the three of them. You can continue to get feedback from your collaborators or clients anytime and anywhere, because it's accessible from everywhere. And then for the next couple of examples about collaboration, I'm going to use the Shanghai Planetary by ENIAD architects. We have a couple of the people who worked on it here, which is very exciting. So the computational design team created a 3D model to understand environmental performance through immersive analytics. So they created a ladybug daylight analysis. That is one of the layers that you will see in the next couple of videos. So the first one that I want to show, so far you could only see on the screen what somebody could see, but you could not interact with that experience at all. So we're going to release very soon this layover menu on the mirrored screen, so that person can really walk the person in VR through the project. They don't have to use the controllers anymore. So the ability to really tell the story of the building, to show that daylight analysis, to get a closer look at, like, taking the other person through the important moments in the project becomes really easy. So most of the operations that you could do directly yourself in VR will be available to you through the menu that you see on the right side. And then this is the third example that I wanted to bring, and this is really exciting. You're getting the first sneak peek into Multiuser. And so we're going to be able to have everybody around the table, like I was showing at the beginning with the physical model. You can section that model. You can have up to 12 people in virtual reality together, and they can be anywhere in the world. And yeah, join the conversation about that building. They can hear each other. If one of them makes a change in the environment, everybody gets to see that. They can point at different objects in the model, have a conversation about what needs to be fixed. They can navigate with each other together. And so the ability to share that environment is key to fully understand what's happening. And again, like being able to select objects, seeing all those properties, so more and more that's going to be available to you. Yeah, here one of my colleagues is drawing something, so yeah, everybody can see that. And yeah, that's what it looked like in VR. So yeah, just to finish, I wanted to tell you about the benefits of using virtual reality in architecture, engineering, and construction. And so the first one is obvious, but you can share an experience and build spaces before breaking ground. This helps our users develop trust and win projects. They can share their portfolio without having to take their clients through or to a site and show them something that has already been built that might be across the world. It allows to save time by streamlining project review and receiving actionable feedback. So what I was showing before, the idea that you can walk out of a VR session with a list of elements that need to be fixed, who made those changes, you can add notes, and being able to make the right decisions and faster. QA and QC is made visual, intuitive, and easy. There is zero abstraction in this means of communication because everybody's seeing the same thing. There's no interpretation of drawings. And then communication is clear across teams. We can get it right the first time around. So I've tried to show you today how virtual reality can support the AEC industry from schematic design all the way into construction. And immersive computing, and particularly VR, can definitely bring us closer together. It can empower us to collaborate more efficiently on increasingly complex projects that were once not possible. I really can't wait to see what we build next with technologies such as these and what's to come with augmented reality. Thank you.